Assalamu alaikum warahmatullah. So, it's a moment to discuss something more on what I can say the Young's double slit experiment. Young's double slit experiment. Okay. When we talk about the Young's double slit experiment, we come across the very important conditions. Likewise, we just try to understand how exactly it's an interference effect that's going to shown by light. And when we talk about this typical experiment, okay, this experiment is not only important by means of the classical way, but this experiment is important in quantum mechanics too, because this experiment is gives some orthodox birth to the quantum mechanics. You can just check the Google Wikipedia and just give this kind of data how it is possible that this experiment is more or less the backbone behind what I can say the quantum mechanics. Okay, and that's a different discussion. I don't want to touch that thing. But here, typically when we talk about the Young's double slit experiment, we just look to the very two important conditions, and that is going to be have with respect to the light waves. That is a condition for the constructive and the destructive interference. But that thing is more or less known to us. I will just look for how we can modify the same experiment in a way like when we talk about the experimental setup of this experiment. If I will just assume that this is my slit first and this is my slit second here and this is my screen here, okay? And screen, you know, it's meant for the results that we want to know after the passage of light rays by means of these two little holes that we call as slits, okay? So for that, I'm just talking about here as if in an ordinary Young's double slit experiment, we just talk about this distance between the two slits. That's what we call as d, okay? If my screen is at a distance of d units apart from these two respective slits here, okay? This is something that we know literally in the Young's double slit experiment, okay? So, but here we'll just look for the modification towards the Young's double slit experiment, okay? Towards the Young's double slit experiment. How we can modify this same experiment? That's my point of interest here. For that, if I will just take my source of light here, okay? If S is my source of light here. For me, this source of light, it is spherically symmetric, means that the light rays will come out from this source through all possible directions, but I don't require here the light rays through all possible directions. I will just require only those light rays which just strikes the two respective slits here, okay? It's my light ray, one of the light ray that strikes one of the edge of the slit, S1, and another light ray strikes at another edge of the slit, S2, okay? So as if it is given in a question that if there exists the initial far difference between the two light rays before they can hit the two slits here, let us assume that the initial power difference between the light rays, it's given here the lambda over 4, okay? 1/4 of the wavelength of the light wave used, okay? So this is what I can say the initial power difference between the two. I will just represent it by del naught, okay? So then after, as if it's known to us that when the light rays they come out through the two slits, okay, they are going to show the disturbance, and such a disturbance is going to measure at this on the screen, okay? For that, as you know, if I will draw some line here and I will just name this point that strikes, that is a representative point on the screen. I will just call this my reference point here, okay, in a way to know the locations of the, as you know, in an Young's double slit experiment, we look for what I can say the positions of respective fringes, whether they can be dark or bright, okay? It is something that's known to us from the Young's double slit experiment. But here what I mean to say, if this is an initial condition that's given from the question, okay? So if the disturbances that come out from the two slits here, if let me assume that this is my one of the light ray here, and this is another light ray. Okay, they are going to, I mean, interact. Okay, as a result of the interference effect, we will have the fringes that are going to form. As we know, it is a story, well-known story from the Young's double slit experiment. But I will not touch such a, I mean, utilization that we are literally come to know in the Young's double slit experiment. This is something that we know, okay? But what's my point of interest here to discuss? If I want to know the conditions for the destructive and the constructive interference, okay? Destructive and the constructive interference in case of the Young's double slit experiment. But if I will just make here the little modification in a way, I have the source of light that emits light rays, and the such a ray strikes the edges of the slits, and we have then after the disturbance, as usually what we are, I mean, going to do in the Young's double slit experiment. If we have this kind of disturbances, okay, and such a disturbances leads to the some fringes here, and such fringes may be dark or bright, okay, depends upon the type of interference. When we talk about the constructive interference, the point P, I would name it as a point P, it will be the representative of what I can say the bright fringe, okay. So I will just make some modifications in a way to this experiment. I have to take into account the initial power difference that the two light rays have before they can hit at some respective positions on the slits and all that, okay. So again, if I want to know my condition for the constructive and the destructive interference, okay, first of all, I'll just calculate here the condition for the constructive interference, taking in account of what I can say the initial power difference as well. If again I will just look for the condition for the constructive interference, taking the account of what I can say the initial power difference here. So what I can say, that what will be the power difference I have usually in the Young's double slit experiment from the two slits onwards, okay. So it will just represent my total power difference del naught plus del, okay, will be equal to, in the case of constructive interval, some integer multiple of the wavelength, okay. This is something that we know from the Young's double slit experiment. This condition is meant for the constructive interference, okay. So how I can just look for this path difference, that will be again the representative of what I can say then constructive interference. Here I can do it this way, and this is a kind of modification I will get here. If I will just put here the value after doing some maths, I will get this condition here, okay. Now I have the power difference here del, and this del is met for the constructive interference, okay. This is a kind of modification that we got in the Young's double slit experiment, taking the consideration of the initial power difference here as well, okay. So likewise, if I will just look for the condition for the destructive interference, taking the account of this initial power difference here, for that I need to look here. When we talk about the destructive case, okay, for destructive interference, the net power difference I will have here, yes, it will be some 2n minus 1 times then half integer of this lambda, okay. So again, if I will just look for here del, that del will be the representative for destructive interference, but it will be somehow modified here because of the initial power difference, that's here lambda by 4, okay. So what I will get here, yes, I will get here 2n minus 1 minus 1 by 2, here it will be lambda over 2, okay. Hope you are getting it. This is a simple mathematical tip here, okay. So after doing one more step here, what I will get, and this del, I can just name this del as del prime, okay. And this is the power difference I will have in case of destructive interference, but in a modified form, because I need to take into account the initial power difference here. Then only then I can modify my experiment here. So it will be 2m minus s, it will be minus 3 by 2 gives lambda over 2. And this is the power difference for destructive case, okay. When we just look for this kind of modification and all that, okay. And I got the two cases. One case that represents the power difference for the constructive interference. Potentially, in this case, when I take into account the initial power difference for the two light waves before they can strike the respective position of the slits and all that, okay, then after the story is as usual as we literally know in the X double slit experiment. But these conditions are, I mean, the representatives of the constructive and the destructive conditions and in a modified form. Okay, this was all about this thing. Thank you.